7.3 Day 2, we're still looking at multivariable linear systems. We're going to use Gaussian elimination to solve systems of linear equations. We're going to solve non-square systems of linear equations. And then we're going to use systems of linear equations in 3 or more variables to model and solve real-life problems. So first, let's talk about number of solutions of a linear system. Note that a graph of a linear equation in 3 variables is a plane. As with a system of linear equations in 2 variables, the number of solutions of a system of linear equations in more than 2 variables must fall into one of 3 categories. So there is exactly one solution, there are infinitely many solutions, and there is no solutions. You learn that the graph of a system of 2 linear equations in 2 variables is a pair of lines that intersect, coincide, or are parallel. So similarly, the graph of a system of 3 linear equations in 3 variables consists of 3 planes in space. These planes must intersect in one point, exactly one solution, which is 710. They intersect in a line or a plane, infinitely many solutions, like 711 and 712, or they have no points in common to all 3 planes, no solution, like figure 713 and 714. Okay, so again, 710 is 1 point. We get an ordered triplet, so we get our x, y, z. So we did in our previous lesson. Then we have infinitely many solutions, which could be one line. Okay, so when you get like a true statement, like 0 equals 0, or one plane. And then no solution is here, so we get an untrue statement, which is an example we did yesterday, like 0 equals 3. Same thing for 714. Okay, so no solutions. So that's what system with 3 variables looks like. Those are our options. So for today, we're going to focus on a system with infinitely many solutions. We did that a little bit in our systems of 2 variables, so let's do it with a system of 3. So let's solve like we did previously. So equation 1, we can leave that as equation 1. And so let's go ahead and add equation 1 to equation 2, and that'll get rid of the x in equation 3. And that'll get rid of the x in equation 3. So this is x plus y minus 3z equals -1. Negative x plus 2y equals 1. So we get 3y minus 3z equals 0. So that's our new equation 3. So let's write it. X plus y minus 3z equals -1. Y minus z equals 0. So that's already, y is a coefficient of 1, so we can leave that. And then we have 3y minus 3z equals 0. So now what we want to do is we're going to multiply -3 to equation 2 and add it to equation 3. So now we have -3y plus 3z equals 0. Then we add 3y minus 3z equals 0. So we notice what we get is we get 0 equals 0. So let's write that. We have x plus y minus 3z equals -1. Y minus z equals 0, and now we have 0 equals 0. So what we need to do is we're going to solve for it like we did before. We need to get an ordered triplet. And so what we're going to do is we are going to, let's solve for this one. Y minus z equals 0. We can say y minus z equals 0 or y equals z. So it's another thing that we can do. So let's let z equal a. Then once we let z equal a, we also know that y also equals a. So just kind of thinking of our ordered triplet here. A is z and so is y. So now let's solve for x here. So let's use the first equation. We have x plus y is a minus 3 times a equals -1. So we solve for x now to get that x value here. So we have x minus 2a equals -1, or x equals 2a minus 1. Okay, so that is our ordered triplet. Let me rewrite it down here. So it is 2a minus 1, a, and a. So go ahead and try that with this system here. Solve the system of linear equations. It is going to be infinitely many. And so just go ahead and let z equal a, and then you'll solve for y, and then you'll also solve for x. So try this out. All right, if you tried this out, you would definitely get 0 equals 0. And so just following the work here, so multiply -2 to equation 1 and equation 2. and I add it together. And so then my new equation 2 is negative y plus 15z equals 13. And then I multiplied negative 3 to equation 1 and added it to equation 3, so working with the other two equations. Then I would get y minus 15z equals negative 13, which is my new equation 3. So you can kind of see already here that it's going to cancel out and become 0 equals 0. So what I did is I took equation 2, I multiplied it by a negative. So notice it's just positive y minus 15z equals negative 13. And then, because I know when I add this together that is 0 equals 0, so I put that here in this place. I know that I need to solve for y, so I went ahead and did that right away. So y equals, I added 15z, so y equals 15z minus 13. Then I'm going to go ahead and let z equals a. So if z equals a, then I know that's my last order triple for my z. Then I'm going to plug it in for my y value, so y equals 15a minus 13. Then I need to solve for x. So I have to plug in everything that I have here. So I have x plus 2y minus 7z equals negative 4 here. So then I plug in what I have. So 2 times y is 15a minus 13, so that's what I plugged in here. Minus 7 times z, and z we said was going to be a. So we plugged in a here. Then you do the algebra involved with it. So distribute. So this is x plus 30a minus 26 minus 7a equals negative 4. Simplify that all the way, you get x equals negative 23a plus 22. So that's what you write as your ordered triplet. You have negative 23a plus 22, then you get 15a minus 13, and then you get z equals a. Now for these, you really could solve for anything. You could let x equals a, you could let y equals a. It's up to you. Generally in the book, it is doing z equals a, so if you're wanting to be able to do that just so you can follow it on Calc Chat, to make sure you are getting the right answer, that might be helpful.